Hey guys, so this is going to go with your foldable that we did in class today. You need to be pausing when you need to write down what I give you. And everything that we do right now needs to be in the foldable, okay? Now, we cut out this definition and pasted it on the side. A function assigns exactly one output, which is y, to each input. So that means x cannot repeat. If x repeats, it's not a function. 4 representations. 1 is ordered pair, 2 is tables, 3 is mappings, and 4 is graphs. You have to know how to go from each one also. So here's the first flap. Okay? We always write ordered pairs in curly braces. And with commas to show each set. Now, to identify a function in ordered pairs, we're going to look and see, does my x repeat or not? 0, 1, 1, 3. So is this one a function? No, not a function. Now let's look at the next one. 0, 5, 2, 6. How about let's just take our pencil real quick and mark this one off. If that one wasn't there, would this be a function? Yes, a function. My bad, I shouldn't have given you 2 that weren't. Okay? So, we know x cannot repeat. Let's do one more. 1, 2, 3, 4. Oh, I don't know what happened. 1, 2, 3, 4, 4, 4, 5, 6. Now, if I have repeating y's, can it be a function? What do you think? Yes, because the output is not what matters. The input what can't repeat. So the input 1, 3, 4, 5 do not repeat. So yes, that's a function also. Okay, now we're talking about tables. Same thing. Can the x repeat? No. The x can never repeat for it to be a function. So on here, looking at our x values only. Does the x repeat? 0, 1, 2. No. So this one is a function. Okay, look at the other one. I do want you to either shade these or make a box around them so you know that's what you're looking at. So, is this one a function? Think about it. Does the x repeat? No. Now, does this matter? Again, output can repeat. The x can't repeat. So that's a function. Now, let's make an example of a non-function. We can put 0, 1, 2, 2, 4, 5, 6, 7. So this is a non-example, not a function. I want you to be able to see both. So x is always on the left or the top. If I had a table this way, the top is the x. Since each input value is paired with only one output value, the relationship is a function. This is important vocab. So put a box around this. Each input value is paired with only one output value. That means it's a function. Each input is an x. Only one output, that's your y. Okay, you guys can make this look nicer. Obviously, I'm doing it on a video. Okay, mapping diagram. When you're doing a mapping diagram, you need to know input is on the left, or x is on the left, y is on the right. If each number only has one arrow coming off of it, that's how you know it's a function. So I'm going to pause this real quick. Okay, in the left circle, write all of your inputs, and the right circle is all the outputs. This is talking about if you're writing your own, which we're going to in a second. Now, looking at this, do any of these arrows go to this, come off the same number? No. 1, 7, 2, 8, 3, 8. If I had to write ordered pairs from this, think about what they would be. 1 would be 1, 7, 2, 8, 3, 8. See, the y value repeats, but not the x. So this one is a function. Looking at this one down here, what would my ordered pairs be? One, 2, 3, 8, 7, 6. When you're writing them in your circles, you also want to write them least to greatest. So starting in smallest order and then increase down. So see how this is the least to the greatest in both circles? That's why the arrows are crossing each other. That's just so it helps with your circles to make them in order. Also, if one of them is going to repeat, so if one of them is not a function, that's where we're going to not repeat it. Don't write it twice. So, again, I want you to box or highlight. Each input value is paired with only one output value. Paired. We forgot that one. This is super important that you remember this. X can't repeat. I'm going to keep saying that. Now, I want you to make a non-example over here. Because we know this is a function and this one's a function. So a non-example would look like if I gave you 1, 2, 3, 4, 5, 6. That's a non-example. Because think about what my ordered pairs would be. It'd be 1, 3, 1, 6, 2, 4, 2, 5. So see how the x's repeat. Non-example. This is not a function. Okay, last one. Now this is the one we're going to go over more in class tomorrow. But imagine if I was going to draw a vertical line anywhere on here, and this vertical line went back and forth, right and left. If there's anywhere on this graph that it would hit 2, if there's anywhere on this graph that it would hit 2 points, it's a non-function. So these are both non-functions. We're going to add one that is a function tomorrow. And it'll make more sense whenever we do the activity tomorrow. So this is not a function, this is not a function. We'll finish this one tomorrow. I know this is a long one, sorry. Now, can you repeat y and it still be a function? Answer this to the right. This is the only question you have. Just yes or no. And here's our little extra for this video. Okay, see y'all tomorrow. We're going to practice functions.